welcome to another brief tutorial for SolidWorks. This time we're just going to have a look at doing a offset truncated oblique cone, and we will be creating a drawing from it as well, just as a reference, so a flat pattern drawing with a reference dimension on it. So we're obviously in the part mode, and we will be creating a sketch on the top plane. So on this sketch, what I found so far, just for my ease of use, when we create this cone, we need to create a circle on the bottom and obviously a circle on the top, and we'll get SolidWorks to join the two together. But because we're going to be having a sheet metal part, what we need to be able to do is have a gap that goes down through there. So this would be like as if you've got a gap in the workshop. Obviously you've got a flat piece, you're going to roll it, get it into the shape you need, and then for example weld it together. So you're going to need to have that gap to simulate a sheet metal part. So that's what we need to do here. So we won't be using a complete circle. You could start with a complete circle and then have a little bit of time mucking around creating a gap in it. I use a center point arc, so I will create a center point arc. Now this is not to try and show you what's best practice in your workshop. You may find that the gap goes best on the short side. This tutorial we're just going to be showing you a gap. I'm not necessarily trying to show what best workshop practice is. So some workshops would prefer to do the weld down the short side, which makes sense. It's not our intention to try and show what's best for you to do, but we are aware that some workshops do their join down the long side, some do them down the short side. So yep, we're just trying to show you how to create a cone. Where and how you put the gap in is entirely up to you. So we've made it a 75mm radius and a 1mm gap. The other thing we need to do is just make sure that the bottom of the arc there and the origin have a horizontal relationship, and that's important for us so we can match up on the top when we create the top cone, or the top sketch for the cone. So we need to now create an auxiliary plane. As you're aware, SolidWorks needs a plane to be able to create something on, or a surface to create a sketch on. So we're going to create an auxiliary plane, and that's under the Features toolbar, Reference Geometry, and we'll click down and we get Plane. Our first reference there, if we just expand this little side feature manager, it's going to be the top plane exactly where we want it. And we want it 100mm above the one that we want. So our sketch is going to be created 100mm above the top plane that we've just used. And because I've been having a play already, that 100mm distance is already in there. It's going to be called plane 1. And we go okay. So, well, this one's plane 2. Because I've been playing with sketches already and having a play getting ready for the tutorial video recording, the one before me was obviously called plane 1, so this is now called plane 2 because it recognizes that there's a difference. You can actually change that if you like. You can go over to here and click on it and change it to, you know, whatever you want. You could just call it an auxiliary plane if you want. So you can actually change that, and you can see it changes over here as well. If we right click on there, choose this icon, normal to, it will swing it around so it's straight onto you. It's easier to see now the for creating your sketch. And if we click on it, we're going to create a sketch, and again we'll go for the center point arc. Just going to do that there. And we're going to make this 35. And to get 1mm again. Now you'll see that the sketch isn't defined. That's because the origin doesn't know where it is in relation. So we will create a horizontal relationship, and it needs a distance, well, because we can move it in and out. So we will define that with a dimension, and we're going to make it 45. And like we did before, we will make the bottom point of the arc and the origin in a horizontal relationship, so that that gap and that gap are in line with each other. And like I said before, might be your workshop practice to have the gaps over the back here because you've got a shorter edge, therefore there's less welding, less distortion, etc. Your workshop practice, but just for the sake of this tutorial, we've done it that way. We can turn this auxiliary plane off. If you're doing more than sort of just a couple of simple sketches, these can get a bit annoying. So if you just right click on the, or just accept the sketch first, sorry, right click in the area and you can, this little pair of glasses comes up, you can hide the plane, just makes it a bit easier. Now what we're going to do is turn on the sheet metal toolbar and go to our lofted bend. Now within the lofted bend property manager here, we're going to have an option of bending it or forming it. We're going to form it because we want to roll it, but if you had a certain shape that might have gone through, say, a press brake, it'll show you the bend lines and all that sort of stuff that'll go there. The other thing to determine at this point is your material thickness, so we're going to set that to 1.2, and SolidWorks here is waiting for an input. Which profiles do you want me to work between? So if we just go over here and click the bottom part of that sketch, you'll see the yellow preview come up. The yellow preview coming up tells you that it is all working. If that preview doesn't come up, then there's an issue with the sketches somewhere and you'll need to go back and edit those and get them fine. So if you're happy with that, you can tick up there or up here. In fact, even if you right click, there's a drop down box for OK there. So various options for accepting that and that you're happy with it. And then we can go to flatten and you'll see that it's working. That's your flat pattern. So you can now save that as a DXF file if you wanted to. You can export it to a DXF format and then save that and email it out, or if you've got an in-house profile cutter, get that DXF file off to the profile cutter for cutting. To ensure that you have sent it in the correct scale, SolidWorks is pretty clever these days, though it'll save it in 1:1 scale, but the next step is to save a drawing of the flat pattern with a reference dimension, so that's what we'll be doing next. Okay, so now that you've saved the cone, we will create a drawing. So very simply, just go to the little drop-down menu, go make drawing from part or assembly, we go OK. If we're going to go for A4 ISO here. If we tick the display sheet format, if we uncheck that so it's not on, it'll just get rid of the title block and leave us with a blank sheet, which is all we need. And we're just going to give us, here's all our various options. We're just going to flick this through, drag it through with your left mouse click onto the page and just drop it there. And you'll see that it's got some fold information. Obviously that's rubbish because you know, of what it is. It's got a rolled product. So you can just get rid of that. Sorry, I've just dragged a projected view up into there. Now that we've got rid of that, we can just go hide, and hide gets rid of those. So what we want to do now is put a reference dimension on here, and the idea of the reference dimension, just a bit of a backup. So say for example you've got you know, 50 of these to go and be profile cut. Before the guy puts them on the machine to cut, you've sent him a DXF. He just wants to make sure as an insurance policy that the scale of the DXF file that you've sent through is going to be appropriate, that you haven't done it half scale or fifth or something. And the boss is going to come and kick your butt because you've had 50 of these made half size. So it's just a good sort of safety thing. So that's an easy dimension for him to pick up with the software that he'll have in his profile cutting software. He'll be able to pick out a dimension or a measurement. You might like to, so you could probably even put one, say, across there, but yeah, probably not quite so usable, but yeah, it can be done. But just a reference dimension, just to check the scale for the guy before he goes ahead and blasts all of these out and makes them the wrong size for you. So there we go. We can save that now as well with your file, with your part. Send the two together as in the instructions and for marking. Okay, catch you later. Cheers. Bye.